In this lesson, we're going to discuss hypothesis testing for the difference between two population proportions. Now, this slide summarizes how to perform hypothesis testing for the difference between two population proportions. So the first thing that you want to do is take two samples, say of size N1 from population 1 and N2 from population 2. And suppose that you get X1 successes in N1 from the first population and X2 successes in the N2 samples taken from population 2. And what we form next are the sample proportions P1 hat and P2 hat. And they're simply X1 over N1 and X2 over N2. Those are your sample proportions. And also, in the case where you're testing equality for the two population proportions, where your P naught is equal to 0, as we'll discuss below, you then form this quantity, PC hat. This is the pooled proportion, where you add together N1 and N2 and X1 and X2, and you calculate this proportion. Now, our hypothesis tests are going to be set up like this. Down here we have the possible tests summarized. So these are the null hypotheses set up here. They're all the same. P1 minus P2 equals some number P naught, that would be given to you in the problem. Now, if this P naught is equal to 0, then your null hypothesis, moving the P2 over to the other side, is simply that your two population proportions are actually equal. This is the case when this P naught is equal to 0. And that's the case where you have to use this pooled proportion up here. So that's our null hypothesis for all of our cases. And then we have our alternate hypotheses set up like this. So our first alternate could be that P1 minus P2 does not equal P0. So the difference between P1 and P2 is not equal to some number P naught. Now, if the P naught is equal to 0, well, then your alternate is simply that the two proportions do not equal each other. You can also have alternate hypotheses set up like this. P1 minus P2 is greater than P naught. In this case, your alternate is simply that P1 is bigger than P2 plus P naught. So in other words, P1 is greater than P2 plus some number. You can also have the alternate hypothesis that P1 minus P2 is less than P naught. And that would be the same as saying that P1 is less than P2 plus P0. So those are our null and alternate hypotheses that we're going to be using. Now, our test statistics are up here. These look complicated, but they're really not that difficult. In the case where P naught is equal to 0, so that's when all of these down here are 0, when all of those are 0, you use this as your test statistic. So you simply have to calculate out the value P1 hat minus P2 hat minus 0, so you don't really need that in there, divided by the square root of this quantity. And notice this quantity right here involves the pooled proportion PC hat. Now, if the P naught does not equal 0, then you use this as your test statistic right here. So now you don't need the pooled proportion down here, so you just calculate P1 hat minus P2 hat minus P0, like up here. Now, in this case down here, the this quantity has been replaced with P naught, divided by the square root of, and you just have to calculate this number out. Now that's going to be your test statistic for the case when P naught does not equal 0. And then over here we have the commands that you can type into Excel to calculate a p-value that you can use to determine whether you should reject or fail to reject the null hypothesis. So once you have your test statistic calculated, you simply have to type these into Excel, and that'll give you back your p-value. If that p-value is less than your significance level, then you reject the null hypothesis. If it's not, you fail to reject the null hypothesis. Now you notice in this case we are using the normal distribution. We're not using the student t. This is a normal distribution type of problem. Now let's take a look at an example from WebWork. So in this problem, a marketing research firm suspects that a particular product has a higher name recognition among college graduates than among high school graduates. So a sample from each population is selected, and each person is asked if they've heard of the product in question. A summary of the sample sizes and number of each group answering yes are given below. So right here's our data. So 96 college graduates were surveyed, 63 recognized the product, 80 high school graduates were surveyed, and 40 recognized the product. Now the company making the product is willing to increase marketing targeted at high school graduates if the difference between college and high school graduates is more than 5%. Let's set up a null and alternate hypothesis that can be used to determine if the company should increase marketing for high school graduates. Okay, so now we have a note here. We are going to use a right-tailed test for this, with P1 being the proportion of college graduates recognizing the product and P2 being the proportion of high school graduates who recognize the product. So we're going to set up our null hypothesis like this. Okay, so our P naught is actually this 5% right here. And our alternate hypothesis, well, the way we want to set that up is, if you read the wording up here, it says that the company is willing to increase marketing targeted at high school graduates if the difference between college and high school graduates is more than 5%. So in other words, if P1, the proportion of college graduates recognizing the product, is bigger than P2 plus 0.05, then the company will increase marketing for high school graduates. So this is going to be our alternate hypothesis. So our alternate hypothesis will be that P1 minus P2 is bigger than 0.05. So you see that's how we just take the P2 over to the other side. And so this is H0 and this is H1 right here. And there we go. We have our null and alternate hypothesis. Now we have to calculate our standardized test statistic. And by the way we enter this into WebWork, I'll put that right in here. We just enter that as okay, so there are the answers for WebWork. Now we have to calculate our standardized test statistic. Okay, so if you recall, we have to calculate these values. P1 hat, well, that's going to be 63 over 96. And P2 hat, That's going to be 40 over 80. All right, now we just have to plug these numbers into the formula for our test statistic, and then we can use the Excel command to calculate a p-value, and then our problem will be finished. Now recall what the formula is. Let's just take a look back at that. Now in this case, the p0 does not equal 0. That's the 0.05, so we're going to use this value as our test statistic. Let's see, I'll just put it right up here. So the p1 hat, that's 63 over 96, minus p2 hat is 40 over 80, then minus 0.05, and then you just have to divide that by the square root. Okay, so we're going to have 63 over 96 times 1 minus p1 hat, so it's going to be and then we need to divide that by n1, which is 96, plus, and then we do the same thing with p2 hat. So that's going to be 40 over 80 times 1 minus 40 over 80 divided by 80. And there you go. That is what our test statistic is going to be for this problem. So let's calculate that out, and when we evaluate this in Excel or on a calculator, here's what we get. And so we get 1.43596. So that is going to be our test statistic. Okay, so let's type that back into the answer slot for web work. So that's our test statistic. Now we have to calculate the p-value. Okay, so going back here, this was a right-tailed test right here. Okay, you see that's how we had it set up. We have it set up as p1 minus p2 is greater than 0.05. That's what we had set up. So this is what we have to type into Excel right here with the 1.43596 right there in place of that z. Okay, so let's do that. Let's bring up Excel. Alright, so here we have Excel open, and then in any cell we just want to type in equals 1 minus norm dot dist of 1.43596 comma 0 comma 1 comma 1, and there is our p-value, 0.075507. Okay, so let's put that back into web work. We can just copy that. Let's go back here. There is our p-value. Okay, let me just clean this up here a little bit. There we go. Now, what was our significance level? Well, the problem said that we should use a significance level of 0.08. So since our p-value is less than 0.08, we would reject the null hypothesis in this case and say that the data supports the alternate hypothesis claim that the percent of college graduates who recognize the product exceeds that of high school graduates by more than 5%. So it does look like this company should increase marketing to high school graduates. Okay, so let's see, we just need to mark off this. We reject H0, and so the company should increase marketing to high school graduates, and that's it. Let's check our answers here. And there we go. It looks like we got everything correct. And once again, when you're doing this problem in WebWork, remember to put in the 0.05 as P0. Don't leave off that first 0 right there. And the same thing down here. It should be entered as 0.05. Just remember to do that. All right. And that concludes this video on performing a hypothesis test for two population proportions.